Well, dear students, in the last lecture, we have developed our idea about the practical and experimental fact why elements combines with each other, right? Now, in this lecture, we will develop idea what is the theoretical concept, how to on the basis of theory, how to explain why elements combine. So this is called electronic theory. Electronic theory, why elements combines with each other, and in this connection, Kosel and Lewis has given the first theoretical approach, basically theoretical approach why elements combine. So as all we are knowing that except helium all noble gases have eight electrons in their valence shell, in their valence shell. And what is the consequence of this? And the result of which they do not combine. See, helium has only 2 electrons. So noble gases have 8 electrons in the valence shell and do not combine with any other element, right? So you can say these are inert. So Kosel and Lewis, they have developed an idea that okay, since noble gases are inert with having 8 electrons in the valence shell except helium, so like this, other elements also try to complete 8 electrons in the valence shell, and due to this, they will combine with each other. So this is the idea behind this electronic theory. So like inert gases or like noble gases, not like noble gases, we can write here to complete the configuration of nearmost noble gas to complete the or to achieve or to complete or attain, we can write the configuration of nearmost noble gas elements combines with each other. And we can say that this theory is a grand success. With few exceptions are everywhere, but majority of compounds and combination of elements can be explained on the basis of this. So mostly have 8 electrons in the valence shell. So you can simplify this statement that elements combines with each other to complete or to have 8 electrons in the valence shell. Right? And this statement is known as what? Octet rule. Octet rule. See, many, you can say almost, except few elements, almost all elements obey this, rule. Octet rule means they have a tendency to have 8 electron or tendency to complete the 8 electrons in the valence shell, right? So see, the approach of Koshel, basically the approach of Koshel was this ionic bond and Lewis of covalent bond, right? But some common feature of Koshel and Lewis approach was that in both the cases, electrons of valence shell are participate in bonding. So electrons of valence shell this is very important point, participate in bond formation. Right? Bond formation. What is a chemical bond? Basically, chemical bond is basically a force of attraction between two atoms. Right? So see, between two atoms, the mandatory condition is two atoms, minimum two atoms should be there, not between the molecule, right? If a force of attraction is present between the molecule, that is not a chemical bond. Although that is a force of attraction, but you cannot say that is a chemical bond. Chemical bond means force of attraction between two atoms. This is mandatory. This is the requirement. See, so how this valence shell electron? See, this is also very important point. How to recognize valence shell? So all of you are knowing that S block, the last shell is the valence shell. For P block elements, last shell is the valence shell. And for D block, last two shells are valence shell, and in F block, last three shells are what? Valence shell. So hopefully all of you are clear in this regard, right? Because I have already explained in periodic table that the S and P block last shell is the valence shell. For D block, last two shells are treated as a valence shell. Although you may have some exception there, that in few of elements have only one valence shell, but in general we are stating like this, that in D block, because if 99% elements showing this, though, what is the problem? If you have some exception, some one or two elements or ions, they may not have last two shells incomplete, right? So valence shell, it is already I have explained you in the periodic table. So how to represent the, any element Lewis representation? Suppose that it is asked Lewis representation presentation. This is common for Koshal and Lewis both theories. Representation of an element. So, for example, if you have taken what hydrogen, so this is, if you have taken lithium, so this is electrons. What I have represented this through a small dot. This is electron and valence shell electron, basically valence shell electron. Suppose that oxygen you have, so 2, 2, 4 and 2, 6. Similarly, if nitrogen you have, so 2, 2, 4 and 1, 5. Similarly, if you have fluorine, so the 2, 2, 4, 2, 6 and 7. Similarly, if you have sodium, then its representation is this. You have magnesium, then it is represented like this. If you have aluminium, so it has 3 electrons, right? So all these are the Lewis representations of elements, Basically here only valence shell electrons are represented. Right? So here only valence shell. Similarly, you may represent many more examples. So this is the Lewis representation, Koshal and Lewis representation of elements, right? So hopefully all of you are clear that why elements combine. So elements combine to complete the 8 electrons in the valence shell in most of the cases. And more general statement is to attain the configuration of nearmost noble gas. For example, if you see here, suppose that we have hydrogen. So hydrogen have only 1 electron. Its the nearmost noble gas is helium. So hydrogen always try to attain the configuration of helium. So hydrogen try to attain the configuration of helium. And one more point is that hydrogen do not have sufficient orbital that it can accommodate the 8 electrons. So this is also called some people they may call this law of duplet. Means hydrogen try to complete the duplet. Similarly, if you come to the lithium, so lithium has only 1 electron in the valence shell. If it loses its electron and forms the Li plus, so it will attain the configuration of helium. This is the configuration of helium, and this is the 2 1. So after loss of 1 electron, minus 1 electron, it is attaining the configuration of helium. But if you want to, if lithium wants to complete the configuration of neon, in which 8 electrons are there in the valence shell, 8 electrons, 2 and 8, and it has 2 and 1, so it has to accept 7 electron, And you know this acceptance of 7 electrons. Okay, lithium can accommodate 8 electrons in the valence shell, but hydrogen not. Hydrogen cannot. Lithium can accommodate, but you will not find any compound, any stable compound in which lithium attains 8 electrons in the valence shell. Remember and carefully listen my words. I am telling that you won't have any stable compound in which lithium can attain 8 electrons in the valence shell. Right? But I am not telling that it cannot, it never achieve this state. It can. But in those states, it is not stable. You cannot isolate those molecules or those systems in the form of a stable system. Lithium can accommodate 8 electrons, and we have some example in which lithium accommodating 8 electrons. Because orbitals are there. What is the problem? See, if you do the electronic configuration of lithium, already all of you have taught this, lithium 1s2 and 2s1 and 2p0. This is a valence shell electronic configuration. Valence shell electronic configuration. Here only one electron is there. So total 8 electrons it can accommodate. So don't deny. Okay, this is practical that in many of its compounds, lithium prefer to attain the configuration of helium, not the neon. So lithium prefer to attain the configuration of helium, right? But it can accommodate 8 electrons, and all the requirements which are required to have 8 electrons, all things are there. Structural features are there in the case of lithium. So this is electronic theory, why elements combine. Now come to the next point, how elements combine. Now we have to answer next question, how elements combine. And we can say types of chemical bonds or bonds, right? Chemical bonds are bonds, not James Bond, right? Types of bonds or chemical bonds. So how elements combine? So now all of you are clear that on the basis of the process of combination, we have different types of bonds or chemical bonds, right? So how these elements are combined, and on the basis of that we have different types of bonds, right? So first method of combination is by transfer of transfer of electron, by the transfer of electron, means transfer of electron from one atom to other atom, means one atom is losing the electron and other atom is gaining the electron. So in the simple words you can say by the loss and gain of electron. Which electrons are used to loss and in gain, loss and gain, or in transfer? Only valence shell electron, right? And this will results the ionic bond. Results the ionic bond. Ionic, right? Clear? Okay. Second method is by the mutual sharing. By the mutual sharing of electrons, and this time they will results the, see, this is the ionic bond, the covalent bond, and third one is by sharing of electron, and this will results coordinate bond or dative bond. Right? So see what is difference between mutual sharing and sharing? See, in mutual sharing, equal number of electrons are participated by both the combining atom. But here in this sharing, the electron pair is provided by only any one atom. So this is the difference between these two. So here in this sharing, electron pair provided by any one atom. So electron pair basically it is provided by any one atom. So this is called coordinate bond. But in modern covalent bonding, there is no place of this coordinate bond. It is replaced by sigma and pi bonds. But I mean, just for information, you should know this. So first, I'm going to discuss here ionic bond, right? Ionic bond. The ionic bond. See, so what is the condition for ionic bond? Condition for the formation of ionic bond. So the condition in which the ionic bond formation is favored. So first condition is one atom should be electropositive, and other participating atom should be electronegative. Right? So suppose that we have this one atom we have taken A and other atom we have taken B. So the electronegativity difference of XA and XB, this should be 2.1. I think it is, I have already explained you in what periodic table. So the ionic character in that bond is more. So ionic character is more than covalent. See, there is one philosophy of this bonding. What in the beginning I want to tell you. The philosophy is that these are the two extremes of bonding. Two extremes. One is ionic and other is covalent. These two are the extreme of bonding, and none of the bond is purely ionic or purely covalent. Most of the molecule will lie between these two. If it is more than 50%, then we can say 50% ionic character, more than 50% ionic character, then it is ionic, and if less, then it is covalent. So this is the philosophy of this ionic versus covalent. Okay, this is philosophy that none of the bond is 100% ionic and 100% covalent. You always think and visualize in a relative sense. Okay, now come to the next point. So see, electropositive character helps in the formation of cation. This will form the cation, and electronegative property helps in the formation of anion. So basically, one atom has tendency to form cation and other atom has tendency to form anion. So this is the first condition, and it should be, you can say that this is the sufficient condition for the ionic bonding. What other condition is required? But listen carefully. One more condition is required, dear students. Suppose that if someone is asked, okay, tell me what kind of bond you are expecting between, I am not taking here A, B, I am taking here some other symbol X plus and Y minus. Suppose that at some point or at some place the question is given, okay, which type of bond you are expecting between X plus and Y minus, right? So you cannot say straightforward that the bond between X plus and Y minus is perfectly ionic or ionic. You cannot say. Think carefully. I have not written the sole condition of ionic bonding is this, that one atom should be electropositive, another is electronegative, or electronegativity difference should be or equal to 2.1. It is a estimated value. Other one more condition is there. That's why I have written here first though. So second condition should be there. At least second condition should be there. That I am trying to explain here. See, we cannot say the bond between cation and anion is always ionic. It depends. It depends. It may or may not be ionic. It depends on the size, relative size of X plus and Y minus. If there is a large difference in the size of cation and anion, the bond becomes covalent. Means covalent character dominates. And if size is comparable, then ionic character dominates. So the second condition of ionic bonding is the size of cation and anion should be comparable, right? If there is a large difference in the size of cation and anion, the covalent character is more than ionic character, right? So we can write, if we can put a note here, if there is a large difference, there is a large difference in the size of anion and cation, the nature of bond, cation, then covalent character dominates. And this can be explained with the help of polarization, right? Can be explained with the help of polarization. Right? So this you can explain with the help of polarization. So now you have two condition, and both conditions should be satisfied by independently. It is not that any one condition can satisfy and you will get the ionic bond, right? So one atom should be electropositive, means have ability to form the cation, and other atom should be electronegative, sufficiently electronegative, means have ability to form anion, and or you can say electronegativity difference should be sufficient between them, and the size of cation and anion should be comparable, and both the conditions should be independently fulfilled. If not, then your bond not necessarily ionic. It may have covalent character, right? Now see, all of you are knowing that if you have taken sodium chloride, so how this formation of sodium chloride we can explain. See, sodium, this is 1 electron in the valence shell, 281, and chlorine, there is 7 electrons in the valence shell. If it will transfer 1 electron to here, so this is 287. Now this becomes Na plus, and 28, and this becomes Cl minus. So it is 2, 8, and 8. Now this is a cation and anion, and we can treat them a point charge. So there is a electrostatic attraction between these two, and this is called what? Ionic bond. This is called ionic bond. Ionic bond, right? So this is a point charge and electric charge we can consider. So suppose that if we put this chloride here on y-axis or on z-axis or anywhere around this sodium, the force of attraction is equal or force of attraction is same, and this force of attraction you can write F is directly proportional to charge over this Z of Na plus, not Z, we can say Q of Na plus, Q of Na plus into Q of Cl minus by R square, right? So you can express this force of attraction between the ionic species by this equation, right? So, and you can say that this bond is, ionic bond which is formed here, it is non-directional in nature, because in all directions electric force of lines are spreaded. So you can put here chlorine or here or here or here or here. The force of attraction is same, right? So this is the magnitude of force of attraction. You can express with this, with the different constants will come here, right? So one very important feature of ionic compound is that this ionic bond is that this bond is what? Non-directional. Means in all direction the extent or the force of attraction is same, right? So the ionic bonds are non-directional. That is, have same magnitude in all directions. That is, have same magnitude of force of attraction, force of attraction in all directions, in all directions, right? So they are non-directional in this sense. Okay. And these ionic compounds, they exist in crystalline solid. So all ionic compounds exist in crystalline solid. Crystalline solid. What are crystalline solid? Crystalline solid have some characteristic feature that all the have regular geometry, have regular geometry, well defined corners, edges, faces, everything is completely defined. Suppose that if you want to know about this sodium chloride crystal, this is the 3D lattice of this sodium chloride crystal is cubic, means this sodium chloride exists in cubic lattice. I am telling you the exact lattice of sodium chloride in which it exists in nature. See, this is a cubic unit cell. This is the one unit cell of sodium chloride. If you take sodium chloride crystal, it has n number of this type of cubic units, right? And the chloride ion exists at each corner. Here chloride, here chloride, here chloride, here, means chloride ions are located at this corner, and each face center of each face means here, 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 and here, right? So this is the position of chloride, corners and center of each face. So chloride ions are center of each face and corner of cube. And sodium ions are look present at the center of each edge. Center of each edge, and one sodium ion is at the center of cube, right? So sodium ion is located. See, this is very, very important point. This is the definition of a lattice, and all ionic compounds will exist in this form, right? So not necessarily in the cubic form, but it may be hexagonal, it may be rhombohedral, it may be tetragonal, it may be cubic. But I mean, meaning is same. Sodium, center of each edge, and center of center of cube, center of cube, right? So this is the, I mean, crystal lattice of sodium chloride, and not the complete lattice, but this is the one unit of lattice, lattice of NaCl. This is one unit. So all ionic compounds exist in the crystalline solid. Means have a definite geometry, have a regular geometry, have sharp edges, sharp faces, sharp corners, right? So this is the characteristic feature of ionic compounds. Hardly you get, or we cannot say that any ionic compound exists in liquid state, right? Okay, naturally it will not exist, but if you put I mean heat strongly this sodium chloride crystal without water and without anything, if you directly put heat on this, so this will molten, will attain the molten state, means it fuse, means it melts, have very high melting point. Ionic compounds, they have high melting point, melting point, and high and sharp, high and sharp melting point. So what is the meaning of sharp melting point? Sharp means, suppose that the melting point of any ionic crystal is, let it be 200 degrees Celsius. So that crystal will not start melting at any temperature below 200 degrees Celsius, and not left to melt above any temperature of 200 degrees Celsius. It will precisely melt at 200 degrees Celsius, not less or not more. And if any material or any solid melts in a range, you immediately say, okay, this is not a pure substance, this is a mixture. Because mixtures have not sharp melting. Or any crystal, if you have any impurity in the crystal, then also it will not have the sharp melting point. So impurity or mixing, that will always decrease the melting point, right? So slowly all of you, I mean, gone through this, all these points. Now see, high and sharp melting point. Other feature is soluble in water, soluble in water, but insoluble in organic solvent. Insoluble in organic solvent. So soluble in water, but insoluble in organic solvent. So definitely I have to discuss in detail what is the solubility criteria for ionic compounds. I will discuss this in detail, right? And conducts electricity, conducts electricity in molten state and in aqueous medium. Aqueous medium, right? So, what is the molten state of any solid? Suppose that you have taken NaCl solid and you just put heat. So, this will melt NaCl liquid, right? So, this is called what? Molten sodium chloride, molten NaCl, right? Only heat, nothing else, no water. And aqueous medium, you put this sodium chloride in water, that is called aqueous medium, right? So these are the few important properties of these ionic compounds, ionic solids. So one point I have to discuss this solubility, but before this I would like to discuss this what I have left here, polarization, right? Polarization.